Our next speaker this afternoon is Steve Evans, CTO for Global Enterprise UK and Ireland, Nokia. And what he wants to talk about, and this is beyond my ken, I must confess, is what is Industry 4.0? So, Steve, over to you.
Well, thanks very much. I just realised I've not been mic'd up, but I hope this still works.
It still works.
Okay. So this is something I was asked to do a few years ago, actually, and I delivered a speech about Industry 4.0 and what it was at the time, 2020, I think. And now we're moving into, a few years past that, and they asked me back to say, what's happened since, what's been going on, and what's next. And it probably won't surprise you that what's after 4 is 5. So we've got lots of things to talk about, but actually, many people would look at this and say, well, what on earth is Industry 4.0? What does it mean to me, and why am I here? Well, if we just go back real quick, Industry 1, this has all been written by somebody else, right? So don't shoot me on this one. This is just, actually, if we go back to the previous presentation, what ChatGPT decided was Industry 1, 2, 3, and 4, so let's give it a go. Originally, back in the 18th century, you got mechanical, steam, then we got electricity in the 19th, 20th, that's the second. Then we got electronics and computers, and how computers helped us achieve our tasks. That's kind of considered the third. And the fourth is where we look into components like AI, IoT, all of these kind of acronyms that we all love. Automatic robots, particularly, and that's something I'll touch on in a bit. And that's considered Industry 4.0. So all of these things coming together to essentially make our lives better. That's the point. And actually, it's a confluence. We've come to a position now where we've actually got a confluence of things that are all coming to fruition at the right time, right? And that's helping us to deliver the kind of services and efficiencies that industry particularly, and we've seen a few people talk about OT industries, so operational telecoms, for example. So how these things can come together. I don't know how familiar you are with all of these terminologies and these concepts, but edge computing, this is basically doing stuff nearer the devices. So if a manufacturing environment, something like Ford or Jaguar or anything that makes things in a huge factory environment, there are end devices, there are robots, there are things that need information and indeed have information. So when this thing asks for information, it goes to a processing location, and that processing location looks at the information, does something with it, sends it back, and the thing acts upon that information. Edge computing just means the processing capability is nearer that end device, and the reason for that is speed. The time it takes for that end device to ask for something and to get a response. Artificial intelligence, well, I'm not going to talk about artificial intelligence because you've had that coming out of your ears, right? I mean, everyone's talked about artificial intelligence. Isn't it great? Apparently we all need it. This is something that's part of the Industry 4.0. There is a degree, I'm being kind of flippant here, but there is a degree of Industry 4.0 with artificial intelligence, and it's about how we look at things called, I love this one, the digital twin. That's another one that's a buzzword bingo, and some of you out there will get house today. And that idea is you can look at all of the data points, map those over to a digital environment, understand what's happening with those data points and what they're doing, and make a change to one or more of those data points and see what happens. That's kind of like the digital twin philosophy. So you can do things to an artificial environment that is mimicking identically the real environment, which is really helpful for heavy industries like oil and gas, for example. Robotics, talked about. The idea about robotics, of course, is they just need connectivity. And they need fast connectivity, not just, you know, let's go and ask it something and a second later you get a response. You're needing like 20 milliseconds or below kind of question and response time to keep these things going. You don't want these robots to go off track, and you know, all of this kind of reminds me of Skynet and Terminator, but well, that's another story. IoT we've talked about. There are thousands and thousands of things that we can look at, monitor, maintain, and there are lots of companies out there that are making these sensors or devices, and actually all the industry that we work with, so I work with energy, rail, transport in general, manufacturing, water, all of these industries need to be able to monitor what's going on at any given time, and the general IoT means that. And AR, VR, MR, good God. So augmented reality. Augmented reality is actually a real thing and is happening and is live in many networks and many industries, particularly manufacturing. Oil and gas is another one. And all that means really is you genuinely have a pair of goggles on, and through those goggles, or a tablet, and through the tablet you can see what it is you're looking at, but overlaid on top of that is real-time feedback on what it is you're looking at, what has gone wrong, and indeed in many cases somebody who is more senior or knows what they're doing can remotely support the engineer that's on site, okay, and that's done in real time. All of these things that we're talking about rely on communication. Okay, so last time I came, it was actually done remotely thanks to COVID, and this is the thing that was kind of causing the problem. So we had all of these things, whether it's in manufacturing, doesn't matter what industry is, there's these things that either need controlling or generate data, and then we have the capability to process that thing or data and do something about it. So we've got all of this data, and we've had this, you know, for decades. This data's always existed, so information about how something is working, whether it's a system or a specific object is working, we've never been able to really take that data and do something with it in a meaningful way that makes our lives better or makes the process easier, more efficient, and so on. Well, Industry 4.0 is enabling that with all of the things I showed you earlier. But originally, it was about communication. How do we get the data from the object to the processing point? And that was quite hard to do. Yeah, okay, Wi-Fi's been around for quite some time, and by the way, this isn't Wi-Fi bashing industry at all. And it did the job in certain circumstances. But in certain other circumstances, it isn't good enough because it doesn't have the coverage, or it doesn't have the security, it doesn't have the mobility. There's lots of things we can talk about why it wasn't good enough. So we had customers coming to us saying, look, we need to be able to connect our things. How do we do it? And the problem was the connectivity to the intelligence from the data. So now the problem is gone away. So we actually have the capability to connect everything now. There are secure mechanisms, robust, reliable mechanisms now from a radio perspective. So how things are connected is all wireless, but it's done in a robust, easily mobile, highly secure way, where things like robots aren't going to get interfered with from a radio perspective. Examples in ports where there's so much interference from other radio devices that stuff stops working. You know, all that these problems have gone away now. So we now have a radio that enables the data to talk to the intelligence. Brilliant. So we tick the box. You know, 4G or 5G technology, particularly 5G technology, isn't it great? Wow. All right, but now we're getting, damn it, now we can see all this information. We actually don't really know what we're going to do with it properly. So we've got all of this Industry 4.0, but how do we actually act upon it all now? And just to be clear, the same principles that we've, you know, been around for years still apply. You know, this is an older slide, as you might see. You still need an end device. They were Ace phones, weren't they? Anyone who's old enough, they last. This is the one you were talking about. This lasts forever. These phones.
6310.
Oh my God! You know, I've still got one in my man drawer, I'm sure. You need some spectrum. So how does the device talk to the radio? You still need a radio. So how does the spectrum come out of the radio, talk to the end device? And damn it, you need a core, right? So the core is the compute, the bit that does the radio network. So these principles have applied for years. You know, this is why your mobile phone works outdoors. It's these four core components, right? And what we've done is moved all of those into a position where we can apply those to the industry environment. Okay, so Ofcom were lovely enough. Ofcom is the body that regulates spectrum in the UK. Ofcom were lovely enough to be able to give enterprises access to that lovely spectrum. That is one of the most prized possessions, and we were allowed to use it, and use it without MNOs, people like EE, O2, Vodafone, getting involved. And any enterprise could come along and say, look, I want some of that spectrum, and Ofcom will go, yep, you can have some of that spectrum in this location, and then they can go and build their own private network. And that's what people like Jaguar Land Rover are doing, Nissan are doing, you know, ports are doing, Southampton Ports, for example, is doing that. All sorts of different industries, BAE, places where they like to explode things and make stuff that goes pop, pop, right? These networks are there, and they're there because they're robust, they're secure, and all of these four components are in place. And that's because the technology is ready. Right, I mentioned the spectrum is ready. There's a whole range of spectrum out there that any enterprise can get their hands on. We've got the core and the RAN. The core and the RAN, what's that? That's what I mentioned before. It's the compute component, and it's the radio bit. Get them from anywhere, you know. Obviously, Nokia makes them, Ericsson makes them. Any number of niche vendors make these kind of products. You can buy them from a number of different vendors. Google it, you'll find loads of different vendors. Use cases. Well, originally, when we started looking at 5G into manufacturing and Industry 4.0 use cases, it was kind of like, you know, 1999, 2000 again. It was, you know, let's build it, and then it'll come along later on. And use cases, well, we'll figure the use cases out. Don't worry about the use cases, we'll get there. Actually now, what we're seeing, and actually that was all funded, by the way, by the government. So the government kind of pushed that out, and that's why we saw the uptake originally. But actually now we're seeing companies coming to us, and the companies are coming to us saying, actually, yeah, we've rolled this out, but now we've got X, Y, and Z use case. We know what we can use it for now. And it's not just one use case where we're connecting a few of the robots. We're now using the same system to connect all of our walkie-talkies together. We're using the same system to connect all the IoT devices together. Right? It's a multi-use case network. And that's what the customers are actually seeing the benefit from. And the use cases I'm looking here, you know, we do so much with manufacturing because that's the obvious one. Robots that move, stuff that needs to be connected and give information back so that we can augment the process to make it more efficient. Oil and gas, from a safety perspective. This same network, by the way, can figure out where people are, make a perimeter, logical perimeter, and figure out if they're straying into danger. Mining, port, energy, rail, we do so much with rail for private networking. Automated trains we're looking at across Europe, for example. Industry 4.0 is, because of the confluence of the different technologies, is starting to create its own use cases. The only downside was the final point there, ecosystem, devices, and endpoints. When we started on this journey, when Ofcom released the spectrum, about 5 years ago now, there weren't any endpoints. And what I mean by that, you know, these things hadn't really developed to the point where they were usable in a let's go down to Curry's and buy it kind of way, which you can do today with Wi-Fi devices, right? Everything has a Wi-Fi device. Well, that's changed now. So now we're in a position, and that's been driven by the industry, actually. The industry's now said, look, we've got to have these end devices, and now they exist, and because the ecosystem exists, if it wasn't for the ecosystem, there wouldn't be a Industry 4.0, right? Now there is the ecosystem. How are we doing for time?
You're doing absolutely great. We've got 15 minutes left.
15 minutes left, okay. So we initially had the bottom bit. You see the bottom bit there? The C and the autonomous action. So we had the connectivity. Right, and this is where we're moving to now. So we can connect everything up, and that's grand. And we can see what's happening. But we also now need a layer where we can understand what's happening from the devices, realize what the environment is, and I mentioned digital twin earlier, but crucially predict what's going to happen. So you have this cycle, okay, where you continuously monitor your devices or your network. And when I say network, I mean something like a manufacturing environment where there's literally thousands of things all connected, right? And they're all pumping information that telling an analytics function what's happening and then what they could do about it to make it better or more efficient, okay? So I want to be clear on the point here. Industry 4.0 isn't just about connectivity, it's about the analysis of the data and what to do with that data. Okay, so what has it delivered? Well, I didn't make this slide, but I do know what it's about. And it delivers enhanced efficiency. Well, what's enhanced efficiency, right? Automated robots. That's an obvious one, right? So now we've got connectivity to these robots. And these are real things. You know, I mean, we use them in our own factory in Finland. You know, we use our own technology to automate everything we possibly can. And these robots do a range of things, right? Whether they're actually manufacturing the circuit boards or simply just literally carrying components from one station to another, right? These things are real and are making huge inroads in the efficiency of operations. The agility component is an interesting one. So one of the things that we getting asked by, particularly people like JLR and Ford and Nissan and people like that, is how do we move stuff around? So they always want to retool, right? It takes a long time to retool. And how do we do that when it's all physically connected? Okay, there's always going to be power, right? But power's a common thing, right? There's always in Europe and UK, always a 3-pin plug everywhere. Getting data to and from the things that manufacture, you don't want to be connected via a fixed line. You want to be a radio connection. And that radio connection enables movement of the product line, okay? So agility in the product line was really important. So the third one, better decision making. Back to digital twin. So you can actually mimic your entire operational set, what is happening and when it's happening, and you can make better decisions because you can see what's happening. And when you make a change, you can see what's going to happen. The safety is an obvious one. Real-time monitoring. We can see everything in real time, right? And we can either alert people. I mean, there are plenty of solutions out there. Things like connected worker on sites where they're in the roadworks of the M6, for example, making a bridge, any kind of connected area where there's construction. You know, all of the people that work in that environment can be monitored. All of the things can be monitored. You know, is the JCB arm going out of the prescribed area? Is it going to cause damage? All of these things can be monitored, right? So safety is an absolute slam dunk for a use case, and if there's any OT industry that relies on safety, it's a no-brainer. And sustainability, this is kind of like, is it? But actually, better processes and efficiency drives a more sustainable business. If you can do things in a more efficient way, then the company becomes more sustainable. I would say we always need to keep an eye, and actually there was a few presentations today about OT. And if you keep an eye on the OT industry, they have some needs that you just can't get around, right? So the security, the reliability, and in many cases mobility, and that means a thing moving around and the radio still being able to connect to it in a secure and reliable way. So we have to make sure we deliver on all of those points. Otherwise, we're not going to get some of the points that you see above. All right. I just want to give you quickly a use case example. This is live, by the way. This is real. This is Lufthansa in Germany. What they do is they do not renovation, but they do maintenance of aircraft engines, and they do it as a service for Boeing and Airbus and co. And they actually use a lot of the, remember I mentioned the confluence of things, the IoT, the connectivity, the edge data center processing. They use all of these things to monitor and look at the engines when they come in. And instead of now Boeing or Airbus having to travel around the world to come to Germany to look at these things, they can all do it all remotely in real time. And they can see stuff that's going wrong with the engines. They can have inputs from Boeing in real time as an augmented overlay, right? So these things aren't pie in the sky, right? This has been live for a few years, and they use 5G technology to connect everything together. Okay. I just want to talk a little bit about the trends, right? So I don't know whether you can. That's probably big enough, I guess. But the major trends we're seeing for spend probably won't surprise you given what I've just said. Transport, utilities, manufacturing. We're also seeing smart cities taking off significantly. This is where the investment's going to go over the next, to the end of the decade. And it's probably not surprising because those industries that I've highlighted are the ones that can easily adopt it and the use cases can be understood and the business case can be signed off based upon the understanding. The one on the right there, 21,000 enterprises, this is a bit old, this is a couple of years old, this information. But this is really important. So we're seeing, I mentioned processing near, right? So near the end devices. That is growing significantly. So taking the processing from data centers, as you may know, Pulse into here, I think, a data center provider. These are centralized locations, maybe 10 across the UK. Well, these industries, particularly the heavy industries, need the information locally, and indeed actually don't want to release the information. They don't trust cloud, right? They want to have the data locally, and they want to have the ability to process that data locally. So it's no surprise to see the statistic there that a lot of the data sovereignty is going to be retained by OT, and the data center capability, the processing capability, will move to the OT site. Okay, and we're seeing that now in the companies that I work with. I mean, the British Aerospace I mentioned earlier, where they make things that explode. There's no way data is moving off that site, so it has to be done locally. Okay. What I wanted to do here, this isn't about, wow, isn't this amazing? This is just about to show you where we see our sales going. So where is it most prevalent, which segment's most prevalent, and which is the region that it goes to most. And you can see, manufacturing, energy, transportation, public sector and smart cities. That's starting to take off a lot. Okay, so as you may not know, local councils and entities are not the most communicative entities, and they are typically siloed and don't talk to each other. It's very common. We see them all across the UK. They all want to make their cities more agile. They always want to make their cities more connected. But it never just works for, let's go monitor the bins, or let's go make it easier for the park people to go monitor the park. So it has to be a holistic view. And actually we're starting to see that, which is why we're seeing it pick up. So smart city is growing significantly. You'll see the region for Europe. Europe, I quite like that because Europe is actually one of the more forward-thinking continents. You'd be surprised with North American market. It's not because we're no good at selling there. It's actually one of our biggest market for revenue. 23% equals more revenue than 39% from Europe, by the way. But it's just that more customers are aligned and are thinking more forward, I guess, about using this technology. They're much more aligned to Industry 4.0. Tech. Well, not sure whether it's worth talking about the tech. NSA, SA, what the hell does that mean to you guys? NSA just means 4G with a bit of 5G. That's what you experience today. It means non-standalone. Why it's called non-standalone, anybody knows. It's not really 5G. It's what you all guys think is 5G when you see the 5G thing on your phone, but it isn't really. NSA, that is standalone. That is pure 5G. It's what we're all hoping we're going to get to one day when 5G really comes along. Isn't it going to be wonderful? No one knows what it's like at the moment out there, unless you work in the industry, unfortunately. It can deliver some stunning performance, but we're not there yet. And actually, the last point there, channel direct, indirect, we go through partners. Partners are the big key here. It's partners like systems integrators and value-added resellers. They're the ones where all the money comes from, and because they are close to the customer, they're the people that do the majority of the business. So, last slide you'll be pleased to hear. This has come from the Nokia kind of, I don't know, what would you call them? The people that look in the crystal balls and then come up with this is what's happening next. Okay, these are, I don't know how much you know about Nokia, but part of Nokia is a company called Bell Labs. Bell Labs makes things like the transistor, amongst other things. And they come up with lots of nice stuff. And they've come up with a vision, and actually you can go and have a look at this. This is all public information. About technology in 2030. And this is kind of like 5.0 now. So we already have the physical world, you know, stuff we know, we can feel, stuff that we can pick up and understand. 4.0 kind of deals with the digital world, right? So how we can translate everything into ones and zeros as a replication almost of the physical world, how the digital world can help the physical world. As we move into 2030 and 5.0, we're going to see interaction with the human world. Now, the human world represents things like our perceptions, our values, our emotions, logic, culture, aspirations. Things that, you know, AI are probably going to help us with, right? So we need to embrace this. This is going to come, and how humans interact with the digital world and how the physical world is bettered is going to be the topic of telecoms, I think. I'm not saying things like heavy oil and gas or, you know, dangerous environments are going to jump onto this, but it's an inexorable path where the human world will meet the physical and digital. And that concludes, I think.
Excellent. Thank you very much. Cheers. Has anybody got a question for Steve at all? Again, we can get a live microphone to you if you want. Okay, I have one question which I want to ask you, and it's more or less the last point that you made. Do you think in the future it will be possible not to interact with the digital world, if you choose not to?
I mean, we're getting into Skynet now, aren't we? So, if you choose, do you know what the honest answer is? I hope so.
Why?
Because I even today, I want to be cut off from time to time, intentionally. So I want to, you know, I want to climb up a mountain and sit there and have my coffee and my flask and my biscuit, you know. I don't want to be bothered with stuff. So hopefully the answer is yes, you can.
What's your instinct, though?
No, you can't.
No. Okay. With that, I'm going to ask you to thank him one more time. Thank you very much, Steve.